Hey y'all, welcome back to the Hack Shack. In today's video, we'll be making our JiffyDOS work without a switch by using just the restore key and whether you're holding it down or not when you turn the power on the C64. So I hope that's something you might be interested in. So stay tuned and let's get right into it.
So if you remember in my first JiffyDOS video, that was just taking a chip from the Go for Retro folks, their version of JiffyDOS, and sticking that in. It comes with a little attached switch and the wire. And what usually people have to do is, drill a hole or just let the wire snake out somewhere, and you have that physical switch to deal with. But I was not really looking forward to doing that, so I wanted to see if I could maybe find a way to do it without a switch, and thought I had heard of something like that before. I remember seeing a video from Adrian where he even had this thing rigged up with a microcontroller and a ROM, so he could use the restore key to switch between 4 ROMs. But that's a little bit fancier. I just wanted basically an off and on for JiffyDOS without having to use a physical switch. This definitely does get my interest though, and I think I will try this one day because it seems very neat. So I took a closer look at the JiffyDOS I had and noticed that that switch was only attaching ground to that pin 13 there. So basically when 13 wasn't touching ground, you had JiffyDOS, and when 13 touched ground, you'd get the original Commodore kernel. With that information in hand, I just kind of went looking around, basically Googling, and came upon this guy's website, which was a simple, JiffyDOS or no JiffyDOS kind of switch setup. This was for like the typical kind of ROM, not for the ROM I had, but I thought that I could probably adapt this to use it because I just needed a way to make the restore key end up pulling that pin 13 down to ground on power on when I wanted to go non-JiffyDOS. So I looked at the schematic the guy had and some of the photos, and I figured I could probably make something like that work. And I was going to just try to do a simple example first to see if I could get it working in kind of a rough manner. So the big piece to this puzzle working is that using this 74HC74 flip-flop chip. Allow us to grab that restore key, and when it goes low, we're going to make the output go low, tying that pin 13 down low. So when we power on the system with the restore held down, we're essentially telling the ROM to boot the Commodore kernel and not the JiffyDOS kernel. I didn't have any of these handy, so I went ahead and ordered up several so I could use them and have some extras in case I messed some up. One of the questions I had, and maybe one that you have too, is why the restore key? Well, if you check this out from one of the Commodore schematics, the restore key is one of those keys that's not really part of the regular keyboard matrix. So I guess that's why it's preferred. So it's an easy one to tell when it's pressed or when it goes low. So that's why it's the preferred key to use for this. Not really possible to do it with the others because of how they are tied to things. So I found an image of one of these 74HC74 chips and just did some quick and dirty hacking to kind of show how I wanted to tie some things together to match his schematic that I was trying to follow. But ultimately, and later on in this project, I found another schematic, and I'm just going to show you that one so you can ignore mine because this was kind of a great one to go by. This one's great, and it just really gets down to brass tacks. Like I said before, this is a dual flip-flop, so we're only going to be using one of the flip-flops in here. So all that pin 13, 12, 11, and 10, we're going to tie to power the VCC 5 volts, which is high, and 14 itself is the voltage for the chip that it needs. You can see that pins 1 and 4 also tie to the 5 volt line there. Then 2 goes to the restore point on the motherboard. 3 goes to the reset point on the motherboard. The pin 5 there is what's going to go over to pin 13 on the ROM chip to tell it, to hold it low so it will do the Commodore kernel. And that destination pin will be different if you're using something else, not this exact Atmel Go for Retro JiffyDOS that I'm using. If you look around, like if you're using a 27C256, that would maybe go to 14, A14, which is technically pin 27. It's just going to vary, but you're only going to go towards the pin 13 if you're doing exactly what I'm doing here. Pins 6, 9, and 8 can just remain floating, and 7 goes to ground. And I just want to reiterate one more time, everything in this video is about the Go for Retro JiffyDOS, which is based on their 2364 flash ROM replacement. And so that is what, its pin for the ROM selection or chip selection, whatever you're going to call it, is going to be in a different place than some other things. So everything I'm doing in this whole video is going to be based on if you're using that. All right, now we're going to get to the first way we tried this out. This is, I call it Deadbug style. It's just real basic. It's like more basic than using a, breadboard or something like that. This is just tacking stuff directly to a chip, jumper wires, legs sticking up in the air, but it works. You don't need much for doing it this way. You need your JiffyDOS. You need some pieces of wire and your flip-flop chip, and that's it. And you're basically going to try to recreate that schematic that I showed earlier, but just by directly tacking things to the chip. So away we go. So I knocked this thing out, and it was working. It did not look very pretty, and but it did work. I don't have a snapshot of it working here, but I'll prove to you later that I've got this working. But I didn't have a capture of it working when I had it in this mode. But yeah, like I said, it's not pretty. You could do something like this, maybe put a little drop of hot glue to hold it down there. Of course, I was excited about having this done. Made a little Twitter post, even saying I was going to get some Perfboard and clean it up. But my old buddy Dave, who is an ex-Navy guy, but he does not put up with any crap wiring. So he gave me a nice thrashing there. So that kind of made me put the spurs to going ahead and trying to do it with Perfboard. That brings us to option 2, Perfboard style. And that's just like, perforated circuit board with sometimes both sides have little solder points on them, but many times just the one side or the other has little circles of solder. You can kind of connect the solder points with extra solder to kind of create little circuit lines. So it kind of works out neat, and it's a lot neater than having a bunch of wires going everywhere. To do this option, you're going to need some Perfboard, the logic chip, your JiffyDOS chip, some different sockets. I've just used different ones. You got to see what works best for you. Pay attention to the diameter and the length because that will be important later. Some individual wires, and I used some wire out of a junk drawer that actually had like a little end on it because when I went to this version, I wanted to be able to take it out completely without having to desolder for the reset and restore line. So this gives me a way to do that. And to do that, I'm using a couple of pin headers like you see in the kind of top right there. And I just try to bend those as close as I can to a 90. And that allows me, that gives me a disconnect point so I can remove it totally without having to worry about desoldering anything if I want to swap it out or work on it or something. Here is where you'll see how you can kind of bridge those together to create, essentially your circuit lines on the Perfboard. You do have to use jumper wires in the instances where you can't make a straight shot with your solder jumping from hole to hole to get to where you need to go. Now, I didn't realize until later, but if you pause, you can look here and see a mistake I've made in one of these clear shots. See if you can find it, and you'll see me correct it later, but that caused me a little bit of headache later on. I wish I would have caught it earlier. Checking here with a meter for shorts and or continuity and adjusting where needed. Here's where I begin cutting this out, and with the JiffyDOS in there, probably not the smartest move, but and it's a mess. This is why my bench is a dusty mess. I should have done this in a different place. So this did not work, and it took me a minute, but I finally figured out what the problem was. Maybe you spotted it earlier, but here I am beginning to fix it.
All right, here we go. Power on without restore. Okay, power off. Power on with restore being held down. We're back to regular Commodore. Then I'll power it off. Power it back on one more time, and you should see that it's back to JiffyDOS. So there we go. That's working. Cool.
At this point, I figured why not go all the way, and why don't we just etch our own PCB to do this I guess the ultimate homemade way. The first and the last time I'd done this was back in March of 2013, so it's been quite a while. I'd purchased some etchant and PCBs with the hopes of doing all these projects back in the day, but never did, and I hunted around to see if I could still find those supplies. As luck would have it, I did still have in my possession a little tote container here with, I had some etchant concentrate, but it's gotten hard as a rock. It may still be fine, but I didn't want to play with it for being able to finish this video. So I actually went ahead and I ordered some Ferric Chloride, and with looks of things, I knew I had plenty of Copper Clad board to pick from, so I was ready to try this out. So to go down this road, we're going to need your JiffyDOS, some sockets, your 7/4 flip-flop chip. You're going to need some Copper Clad board, Ferric Chloride. There are some other things you can do and mix things up, but if you want a surefire thing without mixing, go with the Ferric Chloride. But I'll go ahead and tell you, this stuff will stain anything. So just keep that in mind and try to, wear gloves, well-ventilated area, all the nine yards, all that jazz, all that stuff on that. You'll also need I use pieces of magazine paper, so it's kind of got it's kind of thin, but has a little bit of a gloss on it. I recommend getting a hold of a funnel for when you're putting your Ferric Chloride back up after you use it. And you'll need some kind of container for when you're kind of swishing it around the PCB, and maybe a different one for when you're wanting to soak it in water. And I'll show you why you do that in a little bit. You'll also need some of these little tiny drill bits, just like the ones I've got shown here. I picked these up at Harbor Freight. I think it was like $7-8 for this set. And yeah, you gotta be careful. Ideally, you could use it as some kind of drill press to have like perfect vertical lines. I just used a hand drill, and it was relatively okay, but you could probably do a lot better job with a mini drill press or something. I didn't say it before on the other ones, but it's also a good idea to have a Dremel or something to cut the board out into its final shape. And that would have been applicable also to the Perfboard as well. You'll need access to a laser printer to actually do the toner. That you're going to print these out on this paper with toner, and then you're going to use heat to transfer that to the Copper Clad board. So you gotta have that. You're also going to need I used a clothing iron to apply heat to make the transfer happen. Some folks have used those big thick laminators, but I just used a normal household iron. Next, I needed to find a tool to use to actually draw up the footprint or schematic or whatever you want to call it, so I could print the my transfer, my mask or whatever. If you want to, I needed to be able to design that, and I'd used the Eagle in the past, and I think maybe it's fallen out of favor or something with the open source community. Seems like everyone's using KiCad now. So I went to KiCad.org and downloaded that and gave it a go. Then I just kind of fumbled my way. I used that, I guess, the footprint tool, and I found the footprints that matched the 7/4 chip as well as the 24-pin spacing and all of the ROM chip. And I just kind of figured it out. I did some traces to kind of match up what I had done before. Except in this case, I was able to go straight to my power and ground, so I wouldn't have to run any kind of weird jumpers or anything for that. The only jumper I had to do was from that trace that goes up toward the top that you see here, just to come back up to the top of the board for the ROM select, or to hold that pin 13, so it would hold it low. I just kind of tinkered around in here. I'm in no position to give any kind of tutorial, so I'm not even going to try to do that. I just kind of messed around and figured it out. You could probably do that too. If by some chance you want my weird little file here, I'll be happy to share it. Just let me know in the comments. I'll be glad to put it up somewhere where some folks can get hold of it. After having my design figured out, all I really needed to do was print it out. And you just basically, you can plot, I guess it's called plot, and it'll just make it, to a PDF, and you open that up and print it to, just print it out like on your regular paper, and just to make sure it looks okay. But I'll tell you, make sure that your printer is in, not fit to page or anything like that. You need to print this 100% to scale, or you'll have what I happened here. I'll show you. And it's very frustrating. I had to do this twice because when I printed the copy that I went by, it was at 91% instead of 100%. So nothing's going to line up on your chips and stuff when that happens, of course. Very frustrating. So pay very close attention when you do that. So now back at the bench, I've got my printout out, and I'm just going to cut a piece of the magazine paper out to kind of cover that area. And I'm going to tape it down. And what you're trying to do is send it back through the printer. But, printers are different. It's up to you. You will probably have to experiment if you do this and see which way you want you want to print it back through the same exact orientation. So the space you covered up will get the stuff printed on it when you push it through again. You can see we've gotten it back out of the printer after running it through, and so it's printed on the magazine paper. So then we're going to take that off of this paper kind of gingerly. Next I prepped my Copper Clad board, wiped it down with some acetone. You can also hit it with a Scotch-Brite pad or some steel wool, just kind of get the oxidation off. It'll help things work a little better. That's all you got to do there. Just make sure it's clean, and then you should have gloves on. That way no grease, you don't want any greases or oils from your fingers or skin getting onto the board after you've cleaned it. That'll make you have a less than optimal etching. After the Copper Clad's clean, we want to take the paper with the toner side facing the copper side and wrap it around, secure it. Use a little tape after you kind of roll it around. Just make sure it's secure so it won't really shift around once you get it in place. Now I had my clothing iron set to max and let that get all the way warmed up, and just start applying heat. I mean, the time may vary, obviously don't scorch anything. I think, I may have kind of moved it around a little bit for maybe 2 minutes. You're just trying to get a good, essentially I think you're basically trying to melt that toner and make it stick to the copper, right? That's what's going to be the resist for our transfer. So you may need to experiment on this and see what happens if you do this. Now be careful, that thing will be hot, but afterwards get it and we want to just let it soak in some water. In this case, I ended up letting it soak while I was eating dinner with my family, so it sat there for a bit. Now the longer you let it soak, the better probably, but essentially it's just to kind of loosen it so it'll be less likely to pull off your toner that you have hopefully stuck to the copper. So I just kind of rubbed around on it here and eventually just kind of peeled it off. You can kind of see the circuit lines through there. But this paper is a little different. Some paper is nice and it just kind of will just rub away. But you can see as I go through here, eventually you start seeing the toner has transferred. And I was going to tell you, I didn't say yet, but the reason I did 4, you might be like, we only need 1, because none of these ever, they're never perfect. So I was trying to hedge my bets and did 4. So hopefully I would at least have 1 that was good, that I wouldn't have to do a bunch of rework on. And, basically just rub on this stuff and it'll get the paper off. After you get your board thoroughly dried off, and you get back into a container that you've cleaned out, you want to basically add your Ferric Chloride to it, enough to cover it, maybe enough to cover it and then some. You want to get it covered so you can agitate it. Now one thing, it works better when it's warm. Mine was room temperature, but you kind of put it like in a hot water bath, like in a sink or something, and the warmer you get it, the better it's going to work. And this will take a while. That is the one thing about ferric chloride. I think it's not as fast as some things. I think if you look in Google for yourself, you can mix muriatic acid and I think hydrogen peroxide it makes a pretty good one. There are other things to do, but you know, you can do your own research and see what you want to try out if you decide to try this out. But you want to just do this, and slowly you'll see, like from the edges working in, the copper will start getting eaten away, and it does take a while, or it did for me on this one. But you know, you just gotta keep wiggling. Sometimes I didn't agitate it. I'd left it for several minutes at a time and would come check on it, but it took a good bit. But eventually it will come off. Eventually you'll tell when it's just the you'll see the board backing and all the copper will be gone. When it gets that way, you can go ahead and rinse it off very, very well. Get all of it off, then dry it off, and then you're going to use some acetone like I'm showing here. You're going to put that on a paper towel or a swab or whatever, and you're going to use the acetone to wipe away what's left of the toner and the printer toner. And once you wipe that off, it should just show you the remaining copper traces, and you know, you'll be good to go. Next, I got try to find the closest of the micro drill bits that I had, and started just drilling all these holes out. Not very interesting, so you know, basically just went through. On the outside edge ones I went through later. You'll notice that later in the video those holes got a bit bigger. I had to do that to make some of the later socket work. They had the bigger pins. In this shot you can see where I've test fit the JiffyDOS. Just doing a little basic rough line around it. I might use that to kind of cut by later to at least get kind of close. And then I'll be also test fit the 7-4 chip to see how that fits in the holes that I drilled. Here we're going to be using the rotary tool to go ahead and cut the one out we're going to try to use. Again, wear eye protection and breathing, especially when you're messing with these fiber boards, all this fine dust, you don't want to breathe that junk in. And you only get one pair of eyes, and if that little disc breaks apart and flings something towards your eyes, you don't want that to happen. Got it cut out here, and then I think you'll see me, I'll try to smooth the edges over a little bit here once it pops out. The only thing left to do now is to solder up a few things and fix our socket pins, and it'll be ready to test. Here I had a little trouble getting those reset and restore pins in place, so I just used a piece of socket to kind of hold them, and this is the last little bit here, soldering on the pin that goes up to 13 on the JiffyDOS chip that allows us to switch back to the original kernel when needed. And we're back on. Should be JiffyDOS. Alright, turn it off. Hold the restore key, turn it back on. Should be regular Commodore kernel. And it is. We're going to go off once more and back on. And it should be back to JiffyDOS. And it is. So, I think that works okay. If you made it this far, thanks for watching. We hope to see you again next time. Take care, and bye-bye.